Andrew Huberman in the house. A neuroscientist, professor of neurobiology and ophthalmology at Stanford. You run a lab, Huberman Lab, which is primarily studying brain states such as fear, courage, anxiety, calm, and how it can better move in and out of certain things. So is depression a disease then? Are people who have certain brain chemistry that are born differently with their brains that are just more depressed? Or is it possible to get out of that state if you have the functionality to think, to act, to move, to create routines and habits for yourself? Is that possible?
Yeah, there are some genetic predispositions to depression. And there's certainly familial circumstances where trauma and challenge that can head people down that path. I think one of the reasons I'm involved in public education about neuroscience is I want people to understand the nervous system, and I want them to understand that there are tools that can allow them to intervene in their thoughts and feelings, and most of the time those involve bringing in behaviors and the actual actions, which are very concrete. And the reason is the following: it's very hard to control the mind just using thinking.
It's just using the mind.
Just thinking. It's very hard to, if someone's stressed out and you say calm down, it doesn't work. Telling ourselves calm down doesn't work.
So it's like, what's a tool? Breathe.
Right. So a specific tool.
Go outside for a walk.
A specific tool, right? And when it comes to depression and emotions, it's very hard to talk oneself out of an emotional state. It's just very challenging.
It's very hard.
That's right.
It's like when I talk to my girlfriend and she's just like, she's not happy about something, and she gets on a tangent, I'm like, there's nothing I can say to calm her down. There's nothing I can say to someone who's emotional about an idea in the moment until I'm like, okay, let's talk later. Otherwise, me trying to tell them to relax, no, that's not what you're thinking.
Counterproductive.
That's not what, it's not the truth. That's not what you're thinking or whatever. It's counterproductive, right?
Yeah.
It makes them more emotional.
Well, that's because these states, like these emotional states of mind, they recruit the whole nervous system. So we are actually a different
So your whole body is out of control.
Your mind, your body. Like for instance, if you're angry, upset, or stressed, your pupils dilate. This is subconscious. As a consequence of that, you view the world in a kind of like portrait mode, not panoramic, portrait mode on your phone, where the thing that's upsetting you is in sharper focus and everything else is blurry. So you actually see the world differently. In addition to that, the timing, your perception of time, is now faster, so that things outside you seem to be moving more slowly in comparison to how you feel inside. You've experienced this if you were ever in line at the airport or something and it's taking a long time and you're about to miss your flight. It seems like the person in front of you is moving very slowly.
They're taking forever.
Yeah, but time is time. It's it's moving at the same rate regardless. When you're very calm, or let's say you're fatigued, let's say you're exhausted, you didn't sleep well the night before, things in front of you are going to seem like they're moving really fast. They're saying take off your shoes, putting them on the conveyor, do it. And it's kind of overwhelming.
Like, slow down here.
That's right, because your internal clock is moving more slowly.
Yeah.
And so these states of mind, when someone's upset, they recruit their entire being, their way of being. And so one of the reasons why I mentioned that sensation, perception, feeling, thought, and action before is that the actions are very concrete. And because of this reciprocal relationship between the brain and body, brain connects to body, body connects to brain, we know that when the mind isn't where we want it to be, we need to use the body to intervene.
What does that mean?
So there are two ways that you can shift your brain state quickly. You mentioned one already, which is respiration or breathing. And the reason is there's a direct connection from the brain to an organ in our body called the diaphragm, which is skeletal muscle. The diaphragm is designed to move the lungs up and down, bring in more oxygen, expel more oxygen. And it's unlike other organs like the heart or the spleen or the liver, because it's actually made up of what's called striated muscle, just like a bicep, tricep, or quadricep. It can be voluntarily controlled. You can't voluntarily control your heart directly right now. Like you can't say speed up and speed it up.
Slow down.
Or slow it down.
But you can slow down your breathing,
and
you can slow down the way you think about things, I'm assuming, or change your thought to something else to help you be more relaxed.
That's right. So one of the reasons why breathing is such a powerful tool for shifting one's state is that A, it's always available for voluntary control. It's just right there. I can decide right now to do 3 inhales, or I can just go back to breathing reflexively. I can just do that at any moment. So the neural real estate, which is in the brainstem that controls breathing, is in a unique position because it's at the kind of boundary between conscious control and unconscious control. I can't do that for my digestion. I can't do that for most everything that happens internally. The other thing is that breathing controls our level of alertness very dramatically. So the faster you breathe, generally, the more alert you are. The slower you breathe, the more calm you're going to be.
The faster you breathe, meaning shorter, quick breaths, or
either way. So, so we're just to take a brief adventure through the neuroscience of breathing and how it relates to brain states. And there's some fun tools in here, so forgive me for this tangent, but you have two brain areas that are responsible for breathing. One is called, for the aficionados, the pre-Buttsinger complex. It was discovered by Jack Feldman at UCLA. It's named after a bottle of wine, so now people won't forget it. And it controls rhythmic breathing. So inhale, exhale, inhale, exhale. It's just rhythmic breathing. There's another brain area that controls breathing, which is near what's called the parafacial nucleus, which involves breathing anytime there are double inhales or double exhales or triple inhales. You say, well, why would you have this second brain area for breathing? Well, it turns out when you're speaking or crying or coughing, you need to coordinate your breathing with your speaking, and that means sometimes you need to take multiple inhales or multiple exhales, and this is all happening very, very fast. You don't notice. But there's a very important discovery that was made a few years ago by Jack's lab and by a guy named Mark Krasno at Stanford, who discovered there's a set of neurons in your brainstem, my brainstem, everybody's brainstem, and every mammal's brainstem. It's a very small number of neurons that controls a specific pattern of breathing, which are called physiological sighs. So these are not just sighs where you go and exhale. These are sighs that involve doing 2 inhales and then an extended exhale.
we all do this.
You do this during sleep anytime carbon dioxide levels in your bloodstream get too high, in order to get more oxygen into your system. People also do this if they've been crying or sobbing. They'll do this and then they'll exhale. So what's happening with these physiological sighs and why is this powerful? So your lungs are 2 big bags of air, but they actually are made up of a ton of little sacs of air called the alveoli of the lungs. When we are exercising or when we are sleeping or anytime we're doing anything, these little sacs of air eventually start to collapse. And what happens is carbon dioxide builds up in our system and we experience that as stress. We actually feel the impulse to breathe because carbon dioxide levels get too high. There are neurons that sense carbon dioxide. And then without realizing it, you do a double inhale and then exhale. Typically the inhales are done through the nose and the exhale is done through the mouth. So it looks like. And why the second inhale? Well, if you've ever tried to blow up a balloon for a kid at a kid's party or just blown up a balloon, sometimes blow into that empty balloon, it doesn't go anywhere. So what do? You do two, you go, and then it pops open. So these double inhales pop open the alveoli of the lungs. They don't explode them, but they pop them open, which pulls carbon dioxide out of the bloodstream, brings oxygen, and then you offload carbon dioxide. So if you watch a dog right before it takes a nap or something, it often will do these. Now what's cool about these physiological sighs is from work in our lab, and that's still ongoing, I just want to say it's still ongoing, but work in other labs as well, double inhales followed by an extended exhale are the fastest way that I'm aware of to bring the mind and the body into a more relaxed state.
Really?
Yeah.
The fastest way. So if I'm stressed, I'm overwhelmed, just do a 3 or 2?
2 inhales through the nose, and then exhale slow through the mouth. 1 to 3 of those repeated will bring your level of autonomic arousal down basically to baseline.
What's the autonomic?
It's called
autonomic arousal?
Sorry.
What was it?
Sorry. So the autonomic nervous system, it just means automatic. Yeah, it just means automatic. And it's a misnomer because, as I'm describing, it's not all automatic. I'm sorry. So autonomic arousal is kind of your level of alertness or your level of calm. People sometimes call it sympathetic nervous system, parasympathetic. I avoid sympathetic, parasympathetic, because sympathetic sounds like sympathy, and then people think it means calm and nice, when it actually means stress and freaking
Sympathetic
out.
is stress.
Exactly. The naming...
Parasympathetic is non-stress.
That's right. And those names have to do with the anatomy and the locations of the neurons involved in them.
Sure.
But I think for anyone that experiences anxiety from time to time, which is everybody, knowing that you can consciously take control over these neurons that control the ratio of carbon dioxide and oxygen in your lungs, et cetera. Even if you don't remember any of that, it's just 2 inhales through the nose. What you're trying to do is maximally inflate those little sacs in your lungs and then exhale long through the mouth because you're blowing off carbon dioxide.
I heard you do does it matter the cadence? Because you did a long deep breath and then a shorter?
Not so much.
That's just your style.
Yeah, you're just trying to fill those as big as you can. So the advice that we hear of take a deep breath or just exhale is sort of right, but it doesn't capture this neural circuit. So a lot of what my lab is focused on, because there's so many great labs and people doing great stuff in the breathwork community, Patrick McEwen, Brian McKenzie, there are all these incredible people doing this work, Wim Hof.
Yeah.
But my lab's been mainly focused on what is the neural machinery that controls these brain-body states. And the reason these physiological sides work is partially because you offload carbon dioxide, you reinflate the lungs, so when the body has oxygen, it's happy. When it doesn't have oxygen, it gets stressed. But the other reason is the most direct and fastest connection between the brain and body for controlling your state of mind is what's called the phrenic nerve, P-H-R-E-N-I-C. The phrenic nerve connects these neurons that I'm referring to in these two brain centers that control breathing with the diaphragm. A lot of people get excited about the vagus nerve, and I'm not out to punish the vagus nerve or the veganistas, but the truth is the vagus nerve is a very slow system for calming the brain and body. It's called the rest and digest pathway. People are engaging their vagus all the time when they eat a big meal. When the stomach is distended, it sends a signal to the brain that, oh, I have enough food, it's time to rest and digest. But eating, first of all, if you're only using food as a way to control your stress,
That's not a good habit.
it's not a good habit.
and you'll be depressed one
That's
day.
right. People have learned long ago, thousands of years ago, that the best way to suppress a cortisol response is with carbohydrates because it blunts cortisol. But this is why people eat carbohydrate-rich foods when they're stressed.